Hello everyone. In this video, we are going to solve the problem number 1.67 from Irodov, and that is related to dynamics. So let us first understand the problem and then we will solve the problem step by step. We are having a bar of mass m which is being pulled by means of a thread up an inclined plane, and this particular inclined plane is forming an angle of alpha with the horizontal, and the coefficient of friction between this inclined plane and the bar of mass m is given as k, and it is asking to find the angle beta. For that, the tension in this particular thread will be the minimum one. For that, let us first draw the free body diagram of this mass m. So we will have the gravitational force in the downward direction, that is mg, and then we will have the normal reaction which is perpendicular to this inclined surface, and this inclined surface is making an angle of alpha with the horizontal. Okay, and we are having the tension force which is making an angle of beta with the inclined plane, and we will have the friction force in this particular direction, which we can write it as k into n. Okay, if it is moving in this particular direction with the acceleration of a. Now let us first obtain the forces in the tangential and the normal direction. So forces in tangential direction, if we talk about, then let us say this is our body of mass m, and we are having the component of mg in the tangential direction. So we will have the one component in this direction and another component will be in this particular direction. And if this particular angle is alpha, then this angle will be 90 minus alpha and this angle will be alpha. So this particular component will be mg cos of alpha, and in this direction we will have the component that is mg into sin alpha, and we will have the component of tension in the tangential and the normal direction. In the tangential direction we will have the component that is t cos beta, and in the normal direction we will have the component that is t sin beta. Okay, so let us denote the forces in the tangential direction. So we are having the force of t cos of beta, then we are having k into n in this direction, and then mg sin alpha in this direction, and it is moving with the acceleration of a, let us say. So if we write the force equation in this particular direction, then we can write it as t cos of beta minus mg sin alpha minus k into n is equal to mass into acceleration. So let us say this is our first equation. Now if we denote the forces in normal direction, then this is mass m. We will have mg cos theta in this direction, and we will have the normal reaction plus we are having the t sin beta in this direction. So we can write t sin of beta. As we are not having any acceleration in the normal direction, so we can directly balance the forces in the normal direction. We can write n plus t sin of beta is equal to mg cos of theta, or this is alpha. Okay, so this is mg cos of alpha. Okay, so from here we can say n is equal to mg cos of alpha minus t sin of beta. This is our second equation. Let us substitute the equation 2 in equation 1. So we can write t cos of beta minus mg sin of alpha minus k times, and we can write it as mg cos alpha minus t sin beta, mg cos of alpha minus t sin of beta, that is equal to m into a. If we take the tension as a common, then we will get t times cos of beta plus k times sin of beta, that is equal to ma plus mg sin of alpha plus k times mg cos of alpha. Now if we want to find the minimum value of tension, for that we will make this acceleration as 0, and from here we can get tension force is equal to mg sin alpha plus k times mg cos of alpha whole divided by cos of beta plus k times sin of beta. Okay, now we are having only variable, that is beta, and the angle between the inclined plane and the horizontal direction we are having alpha, and that is constant, and all the terminology in the numerator it is constant. The denominator is variable, which is the function of beta. So let us denote f of beta is equal to cos beta plus k times sine of beta. Now we want to minimize this particular tension force. For that we have to maximize this particular denominator so that overall we can minimize the tension force. Okay, so let us write it as f of beta is equal to cos of beta plus k times sine of beta. In order to maximize this particular function, let us differentiate this particular function. We can write df upon d beta is equal to minus sine beta, that is the differentiation of cos beta, plus k times cos of beta, that is equal to 0. So from here we can write sine of beta is equal to k times cos of beta. So from here we can get tan of beta is equal to k. So this is the value of tan beta we got, and we can also write beta is equal to tan inverse of k. So this is the angle we got for which this particular function will be maximum and the tension will be minimum. So how do we determine that whether the beta that we have found out for which this is the maximum one? For that we have to differentiate df upon d beta again. Let us differentiate with respect to beta. So this is nothing but the second derivative d square f upon d beta square, that is equal to differentiation of minus sine beta is minus cos of beta, plus differentiation of cos beta is minus sine of beta. So this we can write it as minus of cos of beta plus k times sine of beta. So this is a positive quantity, the entire thing is the negative quantity. If d square f upon d beta square is negative, that means we are finding the maximum value of this particular function. If we have found out the maximum value of this particular function, that means we will get the minimum value of this tension force. Now we also have to find out the tension force at this particular value of beta. So we are given with tan beta is equal to k. That means if we draw this particular triangle and let us say if it is beta, then we can say this is k, this is 1, and this particular distance will be 1 plus k square under root. Okay, so from here we can write sine of beta is equal to k times k divided by k square plus 1 under root, and cos beta is equal to 1 divided by k square plus 1 under root. Let us substitute the value of sine beta and cos beta in the expression of this tension force. So we can write tension force is equal to mg sin alpha plus k times mg cos alpha. So mg sin alpha plus k times mg cos alpha whole divided by cos beta plus k times sin beta, cos beta plus k times sin of beta. Let us substitute the value of sin beta and cos beta here. So we will get mg times sin alpha plus k cos alpha whole divided by cos beta is 1 upon k square plus 1 under root, plus k times sin beta is k divided by k square plus 1 under root. So from here we can get mg times sin alpha plus k cos of alpha whole divided by 1 plus k square whole divided by k square plus 1 under root. So from here we will get tension force, which is the minimum tension force, that is equal to mg times sin alpha plus k times cos of alpha whole divided by 1 plus k square under root. So this is the value of minimum tension force we got for the beta value is equal to tan inverse of k. So I hope the entire procedure is clear. Thank you.